Welcome back to the deep dive. If you've ever built a web application, you've probably hit that point, right?
Yeah.
You click something and just waiting. That spinning wheel.
Oh yeah, the dreaded spinner.
Exactly. And often that's because the app is like trying to do something huge in the background, sending out tons of emails maybe, or crunching a big file.
Right. Things that shouldn't really block the user interface.
Absolutely. If they run synchronously, the whole thing just grinds to a halt. You get slow responses, frustrated users.
Yeah.
We've all been there, clicking reload frantically.
Definitely.
So today we're doing a deep dive into how Python developers actually solve this. We're looking at task queues, and specifically we're comparing two really popular ones, Celery and ARQ.
That's the plan.
Okay.
Our mission here is to sort of pull out the key insights from the sources we looked at, help you understand, the core problem, how these tools tackle it, because they do it quite differently. And the big question, when you should pick one over the other.
Yeah.
Because they both solve that same issue, task queuing. But their whole approach, their philosophy, it's pretty distinct.
Okay, so let's maybe flesh out why these background tasks are so critical. You mentioned emails, like someone signs up, you want to send a welcome email.
Standard stuff, yeah.
But if your app just sits there waiting for the email server to respond before saying, okay, you're registered, that feels, well, clunky.
It does. It adds noticeable delay for the user for something that doesn't need to be immediate.
And it's not just emails, is it? There's file processing.
Huge files, yeah. Uploads that need resizing or analysis.
Or like scheduled jobs, cleaning up old data.
Definitely. Daily cleanups, weekly reports, anything that needs to run on a schedule, or even talking to external APIs that might be slow sometimes. You don't want your app waiting on those.
Right. If you don't handle that async, your main app just slows right down. Affects everyone using it.
Exactly. And that's precisely where task queues come in. They let your application basically fire and forget these jobs.
Fire and forget. I like that.
Yeah, you just toss the task onto a queue. Then somewhere else, you have these dedicated worker processes. They just pick up tasks from the queue and do the work. Totally separate.
So the main apps stay snappy.
Exactly. The user gets that instant feedback they expect, and all the heavy lifting happens quietly behind the scenes.
Okay, so when we talk Python task queues, one name always comes up first. Celery. It's called battle-tested, distributed. What's the story there? Why has it been such a mainstay?
Well, its maturity is a huge factor. It's been around. It's stable. Battle-tested is the right word. And it's incredibly versatile.
How so?
It's broker support, mainly. It works with RabbitMQ, Redis, SQS, lots of options. So you can often plug it into whatever messaging system you might already have. That's a big deal for larger setups.
Okay, flexibility.
And it scales. I mean, it's built to handle potentially millions of tasks across many machines. Plus, it's got a really rich feature set baked in.
Like what kind of features?
Things like automatic retries if a task fails, a way to store task results, see if it succeeded or what the output was. And monitoring tools, Flower is a well-known one, gives you a web UI to see what's going on.
A dashboard, basically.
Yeah, proper dashboard. And it handles scheduled tasks, too, using a thing called Celery Beat. That's its scheduler. Oh, and because it's been around so long, there's a decent ecosystem of extensions and libraries built around it.
That sounds really comprehensive,
Yeah.
almost. Potentially too comprehensive. The sources hint it might be overkill for smaller projects. What does that mean in practice, like beyond just setting it up?
That's a really good point. It's not just the initial setup, though that can be more involved. It's more about the architecture. Celery runs with dedicated worker processes, often multiple Python processes.
Okay.
So you're essentially managing a small distributed system right from the start. That adds complexity to your local development setup, to debugging, to deployment. It's more moving parts compared to something more integrated.
So more mental overhead for the team.
Exactly. It's fantastic when you need that power, like for complex video encoding pipelines or massive email bursts, especially with Django or Flask apps. But for simpler stuff, that complexity can feel, well, heavy. It really shines when you have lots of workers, maybe, 10 or more, doing heavy data processing.
Right. Makes sense. So if Celery is the experienced veteran, ARQ is positioned as the modern async contender, specifically for async Python.
Yeah, exactly. ARQ, which stands for Async Redis Queue, is built from the ground up for Asyncio.
So async native, what does that actually give you? And are there downsides to being so focused?
What it gives you is simplicity and efficiency within an async context. It's designed purely for async await. And its backend is just Redis, only Redis.
Just Redis, okay.
Yeah, which simplifies setup quite a bit. No need to choose or configure different brokers. And its footprint is described as tiny. A key difference is that ARQ workers run inside your main async event loop.
Wait, inside the main application loop?
Often, yes, or at least sharing the same loop structure. It means it leverages Python's asyncio concurrency model directly. You can often handle many concurrent I/O-bound tasks within a single worker process much more efficiently than spinning up multiple OS processes like Celery typically does.
Ah, okay. So potentially less memory, simpler deployment for pure async stuff.
Potentially, yes.
Yeah.
And configuration is simpler too. It doesn't need a separate beat scheduler for periodic tasks. That logic is integrated more directly.
That focus sounds really appealing for certain kinds of apps, but like you said, trade-offs. What do you lose by going with ARQ?
Well, the flip side of that Redis-only focus is, it's Redis-only. No RabbitMQ, no SQS. If you need those, ARQ isn't your tool.
Right. Locked into Redis.
And it's younger. The ecosystem isn't as mature as Celery's. Fewer third-party extensions, less community history perhaps. And there's no direct equivalent to that Flower monitoring dashboard.
Okay, no fancy GUI.
Not built in, no. So it's really geared towards, say, small to medium FastAPI apps, where you're already deep in the async world and just need simple, efficient, Redis-based task queuing. Async HTTP calls are a classic example where it fits perfectly.
Okay, this is crystallizing, which brings us right to the core question for anyone listening. All right, which one do I pick? When is ARQ the clear winner, and when should I stick with or choose Celery?
Let's try and nail that down. ARQ is likely your best bet if you're building with FastAPI or Starlet, something async native. You want that native async await feel for your tasks. And you're happy using Redis. Maybe you already use it for caching or something else.
So small, modern, async, Redis-based apps.
Pretty much. Perfect for those, especially if tasks involve async I/O, like calling other web services. Now, Celery is probably the better choice if you're using Django or Flask, the more traditional frameworks. Or if you specifically need to use a different broker, like RabbitMQ, maybe your organization already uses it heavily. Also, if you need those really advanced monitoring features like Flower or complex retry logic for critical tasks, and as we said, for really heavy data pipelines with lots of worker processes needed.
10+ workers, you mentioned.
Yeah, where the distributed nature is a strength, not just overhead.
Gotcha. And let's quickly revisit that fire and forget email example just to make it concrete. How does it look in both?
Right. So with Flask and Celery user registers, your Flask route handler immediately returns success to the user. Then it calls a Celery task like send welcome email.delay, user read. Celery puts that job in the queue, Redis, RabbitMQ, whatever, and a separate Celery worker picks it up later. User isn't waiting.
Okay. And ARQ with FastAPI.
Very similar concept, just using async syntax. Your FastAPI endpoint would register the user, maybe await user.save, then immediately await CTX or caddis's.enqueue job. Send welcome mail, user it. It returns success to the user instantly. The ARQ worker, running in his async loop, picks up the job from Redis later. Same outcome. User doesn't wait.
Perfect. The core idea is the same, offload the waiting.
Exactly. So, recapping the main difference. Celery is the feature-rich, highly configurable, broker-flexible workhorse, great for larger, potentially more traditional apps or complex distributed needs.
The Swiss Army knife, maybe?
Kind of, yeah. Whereas ARQ is the lean, mean async machine. Modern, lightweight, specifically for async Python and Redis. Simpler, perhaps, but more focused.
It really does boil down to your specific project, doesn't it? Your stack, your scale, how much complexity you're willing to manage versus how much flexibility you need.
Absolutely. There's no single best answer, only the right answer for your context. Understanding both options is super valuable, though.
Definitely. Knowing these tools exist and when to reach for them is key for building performant Python web apps.
For sure. It can make a huge difference to the user experience and your own development sanity.
So that was a great breakdown. It leaves me thinking, though, with Python's async capabilities still evolving pretty fast, how might that shape what comes next in task queues? Will we see more tools like ARQ or maybe Celery adapting more deeply? It's interesting to ponder.
That's a fascinating question. Food for thought. For now, we really encourage you, the listener, to think about your own projects, current or future. Which of these approaches feels like a better fit? And definitely check out the documentation for both Celery and ARQ to dig even deeper.